All right, we're going to do section 5.4, okay, which is continuing to talk about polynomials. So when we have a polynomial like this, f of x is equal to x plus 1 times x minus 2 cubed. Okay, that's a cube behind there. They're going to talk about graphing things like this. Okay, so the first thing we got to do is talk about degree. And same thing like we've done in 5.1, 5.2, 5.3, the degree is just the highest exponent. Okay, so again, we get x from this one, and we get x from this one, but it's cubed. Okay, so technically the degree would be x and then x cubed, which would be x to the fourth. Okay, so our degree is the exponent, so that's going to be 4. Now, the next thing they're going to ask for is the y-intercept. So anytime you see y-intercept, you're going to set x equals 0 and solve. Okay, so if x equals 0, so I'm going to get y is equal to 0 plus 1, 0 minus 2 cubed, okay, which is the same thing as 1 times negative 2 cubed, which is equal to negative 8. Okay, so my y-intercept is going to be 0, negative 8. Next thing will be the x-intercept. Okay, so the x-intercept is the same thing that we have been doing. Set y equal to 0. I'm going to go 0 is equal to x plus 1, x minus 2 cubed. Okay, so both these could be 0, so it's going to be x plus 1 is equal to 0. And x minus 2 cubed is equal to 0. So the first one would be x equals negative 1. And the last one would be 2. But notice, this one's cubed. Okay, so it could be 2 the first time. So this technically says x minus 2 times x minus 2 times x minus 2 is equal to 0. So how many times would this be 2? That would be 3. So that's why these are 3 solutions and that's 1. Okay, but technically your x-intercepts are going to be negative 1 and 2, 0. Okay, so those would be those 2. Now, the next question asks, find the 0 at which x flattens out. So we talked about when it's squared, how it hits and comes back. So let's go back. Let's just say it's singular. Then the graph looks something like that. It would hit and go down. Now, if it's squared, it's going to hit and come right back. Okay, so this would be squared. This would be a single x value at that point. Okay, but notice this one, how it's cubed. Okay, this one's going to be called, if it's cubed, it's going to hit, but then it's going to look like it flattens out a little bit, and then it comes back down. Okay, so when it's cubed, it's going to be called flattens out. So if they ever ask, when does it flatten out? It's when your value is cubed. Okay, so on the last one, find the 0 which f flattens out. That's for your cubed function, whichever one happens 3 times. And if it doesn't happen 3 times, then it's nothing. Okay, so the 0 which it flattens out is the 0.20. This would be the flattened one. Okay, all right. All right, so the next thing we got to figure out is we got to find zeros where it's something other than where it's already, because these are linear factors. That's what those are. Okay, so when it's not linear factors, how do we do that? So let's clear this. So the next one is f of x is equal to x cubed minus 11x squared plus 40x minus 50. Okay, so back from 5.3, you remember how we did this was we had to find the leading coefficient, which is the highest degree. So notice that it's a cube. Okay, so we have to have 3 answers. Again, this is the leading coefficient, or this is the leading value, and this is the constant. Okay, so the degree, we need to figure that out first because that'll tell you how many answers it has. So the degree is 3 with the leading coefficient of 1. Notice the value in front of this. So we also need the factors of that. The factors of 1 is just 1. Okay. So then we have the constant. And since it's going to be plus or minus, really the negative doesn't matter. And then we need factors of that. And the factors of 50 are 1, 2, 5, 10, 25, and 50. Remember, these are the p-values. These are the q-values. And then it's to find your possible solutions, it's plus or minus p over q. Okay, so my possible solutions are going to be plus or minus 1 over 1, which is 1, plus or minus 2 over 1, I guess I should have just wrote 2. Plus or minus 5, plus or minus 10, plus or minus 25, plus or minus 50. Okay, so those are your answers, possible answers. So that would be 2 there, 4, 6, 8, 10, 12 possible solutions to this equation. Okay, and again, how do we figure that out? Well, we just start plugging them in. Okay, and we just guess and check. Okay, once we find 1, we'll use it to use synthetic division to go down to x squared, and then we can use quadratic. Then we can just get the answers. Otherwise, you'll sit here and plug all 12 of these in. Okay, and it might not even be any of these. It might be a complex solution somewhere. Okay, something with the square root in it. So let's start with 1. 1, negative 11, 40, negative 50. Bring down to 1. 1 times 1, make sure to put your plus signs. It's 1, negative 10, negative 10, 30, 30, negative 20. So is 1 a solution? Okay, again, you look at this number. If it's 0, it's yes. If it's anything else, it's no. So 1 is not 1. Okay, now I can keep going on these. And you will, but I'm going to guess 5 next. 1, negative 11, 40, negative 50. 1 times 5 is 5, so that's negative 6, negative 30, 10, 50, and that's 0. So 5 is 1. Okay, so if I put my solutions down here, 5 is 1. Now I need 2 more. Still need 2. So I can use use this and do quadratic. Okay, so I'm down to, since this was x cubed, this is now x squared. So my right here is x squared minus 6x plus 10. What I have left. So my a value is 1, my b value is negative 6, and my c value is 10. So when I plug it in, it's negative b, which is negative 6, plus or minus the square root, b squared, so negative 6 squared, minus 4 times 1 times 10, all over 2 times a, 2 times 1, which is going to equal 6 plus or minus radical. Negative 6 squared is positive 36 minus 40 over 2. Okay, that equals 6 plus or minus radical negative 4 over 2, which is equal to 6 plus or minus square root of negative 4 is 2i over 2. And then lastly, I can divide both by 2, so it's 3 plus or minus I. Okay, so notice 3 plus I is the solution and 3 minus I is a solution. 3 minus I. Okay, so those are your 3 solutions to those. Notice that when 3 plus I is a solution, you have to have 3 minus I, right? Because it's plus or minus in this. So anytime you get an I or something with a radical in it, okay, it has to be plus or minus. So it has to be this b value plus that number and the b value minus that number. So if 3 plus I is a solution, you always know that 3 minus I is a solution, okay? That's important to know. All right, so the next one. Given that negative 7i is a 0, so I know 1, 0, negative 7i. Factor the polynomial function completely. Use the conjugate roots theorem if applicable. Okay, so my equation is f of x is equal to x to the fourth minus 11x cubed plus 77x squared minus 539x plus 1,372. Okay, so I know 1, 0, but technically, since it's an I, just like what we talked about, the conjugate roots theorem says if negative 7i is a 0, so is 7i. Okay, remember how we did the plus or minus thing on the problem before? Okay, so minus 7i is 1, so is positive 7i. Okay, so this is good because I can use synthetic and just take out both of these, and then I get down to x squared. Since I have x to the fourth, I have 4 solutions. Okay, so when I divide out both of these, I should be down to 2, and then I can use quadratic. So I don't even have to use the guess and check method here. Okay, so 1, negative 11, 77, negative 539, and 1,372. Okay, and let's do negative 7i first. Okay, so you bring down the 1. So 1 times negative 7i is negative 7i. And then you can't do anything because yours are not like terms. So it's negative 11 minus 7i. Now you just FOIL. Negative 11 times negative 7i is 77i. And then negative 7i times negative 7i is positive 49i squared. But remember, I squared is negative 1. Okay, so this should become minus 49. Okay, add that to 77. I should get 77i plus 28. FOIL again, 77i times negative 7i. I squared would be negative 1, so that should turn this to a positive. So positive 539 is 77 times 7 is 539. 28 times negative 7 is negative 196i. Okay. Add those together. Notice that crosses off, so I'm down to negative 196i. And then multiply these two out, and you get negative 1,372. 0. Okay. Notice you got a 0. If that wasn't 0, you didn't do it right. Okay. So we're going to use synthetic division one more time with the results from this. And we're going to do it with positive 7i. So you bring down the 1. 1 times 7i is 7i. Notice the i's cross off. 7i and 7i cross off, so I'm left with negative 11. Negative 11 times 7i is negative 77i. So see how this is looking a little cleaner. So 77i minus 77i is 28. 28's left. 28 times negative 7i is, let's see, what would they, positive 196i. Those cross off and you get 0. So since this was x to the fourth, this is now x cubed, this is now x squared. So I'm left with x squared minus 11x plus 28. Okay. So the next thing I can do, I know it's equal to 0. I got to find the other 2. Okay, so I can use quadratic, where this is a, b, c, or I could try to factor. Okay, I would always try to factor first. Is there 2 numbers that multiply up to 28 but add up to negative 11? And it's negative 7 and negative 4. So my 2 answers, x equals 7 and x equals 4. Okay, so I have 1 answer, 2, 3, 4. So my solution set would be negative 7i, positive 7i, 4, and 7. Notice that these have to match up to the degree. Okay. All right. Construct a polynomial function with the following properties. Okay, so we have to construct that polynomial. It has to be third degree. So that means the power of 3. So I need 3 solutions. It has real solutions of 4. Says the answers are -4 and 2 plus I. Okay, but now I only have 2 solutions. I need a third. Well, if I have 2 plus I as one solution, 2 minus I has to be the other one. All right. So now I have 3 solutions. All I have to do is make a polynomial. Okay, so let's write the linear factors first. So P of X equals, remember, we're always going to put the C. We got to put some multiplier here just in case they want a y-intercept different than what it might be. Okay, so this would be x minus this value, x minus -4, x minus 2 plus I, x minus 2 minus I. Okay, so people screw up because they just put the minus and then they forget to distribute the minus to both. Okay, so P of X, it's going to be x plus 4, x minus 2 minus I, x minus 2 plus I. Okay, so now we're pretty well done. We just need to FOIL these. So my P of X is equal to C. Always do these two first, because then it gets a lot simpler. X plus 4. When you FOIL that, x times x is x squared. X times -2 is -2x. Plus ix. And then go to -2, -2x. Positive 4. -2i. Keep going. Okay. Let's see. -2 times I was -2i. -ix would be the next one. -I times -2 is positive 2i. And -I times I would be -I squared. Remember, this is the same thing as -1. Oh, I don't really like that. So it would be minus -1. Okay, which in turn would mean this at the end would be plus 1. Okay, so let's simplify. P of X is equal to C, x plus 4. X squared, there's no other x squared. -2x and -2x would be minus 4x. Ix and -ix, those will cross off. -2i and 2i, those will cross off. And I'm left with 4 plus 1, which is 5. See how much easier that looks now? FOIL that. That would be x cubed minus 4x squared plus 5x plus 4x squared minus 16x plus 20. Simplify. X cubed. X squared would be -4x squared and 4x squared. Those cross off. 5x and -16x would be minus 11x and plus 20. Now I am almost done, except I got to find the C. Okay, now it says y-intercept is -20. The y-intercept is -20. Okay, so that means at x equals 0, y needs to be -20. Okay, so I need to plug x equals 0 in and my y value here. So with this information, I could say -20 is equal to whatever c value times 0 cubed minus 11 times 0 plus 20. And I got to solve for c. So that would say -20 is equal to c times 0 cubed is 0 minus 0 plus 20. So -20 is equal to c times 20. So divide off 20 and I get C equals -1. So now I come back to my final, which is this, and I just need that C value. So my answer is going to be, I'll write it right here, P of X equal to negative times everything in there. X cubed minus 11x plus 20. Okay, that would be section 5.4. Please let me know if you have any questions.